Hello everyone and very warm welcome to this video lecture series in which we are going to learn about neural networks and deep learning. So now this is the third video lecture in this lecture series, and in this lecture we are going to see that why is deep learning taking off these days. So deep learning and neural networks is not quite a new concept that we are learning nowadays, but it is a very old concept that was running now. So many of you may have a question in your mind that deep learning and neural network was basically introduced to the society very long ago. But what is the reason that deep learning and neural networks is taking off so frequently these days? So let us answer this question in this video lecture. So let us continue. Now, here you can see this graph, and in this graph, the x-axis basically represents the amount of data that we have, and the y-axis represents the performance of the algorithm. Here, by performance, we mean that the accuracy of the algorithm. Suppose we train an algorithm, and how much accuracy this algorithm has achieved while training the, so this basically represents the performance of the algorithm that we are using in correspondence to the amount of data that we are using. So let us draw something on this graph. Okay, so let us draw a curve. So here I'm drawing this curve. So as you can see here, this is the curve that we are drawing for the traditional learning algorithms. So let me write here. So this is the graph that I've drawn for traditional learning algorithm. By traditional learning algorithm, we means that we have learned traditional learning algorithm like support vector machines or logistic regression, etc. So these are the traditional machine learning algorithms. So basically what this curve basically implies to you that for the particular amount of data, this is the performance graph of the traditional learning algorithm, where when you have some small amount of data, the performance of the learning algorithm is increasing to a particular extent, and after that increasing to a particular extent it gets somewhat constant. So now if you apply more and more data to this learning algorithm, then there is not much significant increase in the performance of the algorithm, and the performance of the algorithm has now become quite a constant. Okay, so this was the performance of the traditional learning algorithm. But now our society has significantly been to the advancement, and after the advancement we have introduced some new concepts like neural networks. And after applying the neural networks, this is the performance of when we apply neural networks to the data that we have. So let us draw this curve by using a different color. Okay, so this is the curve that we get when we train somewhat a smaller neural network on the data that we have. So you can see that the performance of algorithm has consistently been increased in comparison when we use traditional learning algorithm on our data. So this is the basic advancement when we use neural networks. And now suppose that if we have somewhat a bigger neural network. Now if we have somewhat a bigger neural network, so let us draw the curve for that. So here is the curve for that. If we have medium sized neural network. Okay, so this is the graph when we have a medium sized neural network, and the medium sized neural network performs much better than the performance we have seen in a smaller neural network or in case of the traditional learning algorithms. Okay, and suppose that if we have a neural network that is much bigger than this, then what sort of performance we can see? I'll draw it on the graph. Okay, I'll take a yellow color to draw the performance of this kind of learning algorithm. This also goes somewhat straight after performing to some extent, and this is a large neural network. So what you can see, as you increase the size of the neural network, the performance of the learning algorithm consistently increases a lot. And along with the size of the neural network, the amount of the data plays a very important role if you want to have a very better performance of the learning algorithm. So basically what we mean by the amount of data, let me change the color of ink. Okay. So what we mean by the amount of data is we mean basically the amount of the labeled data, because we have already seen that the neural networks and these algorithm comparatively performs much better when we have a labeled kind of a data. And by labeled kind of data, here we mean that we have a lot more number of training examples, and in our symbolization, we represent the training examples by the x comma y subset. And by x we mean that the x is the input features, and y is the output corresponding to the input x. So as we increase the amount of data, the learning algorithm performance consistently increases. And also the performance increases when we use somewhat advanced algorithm, like we shifted from traditional learning algorithms to smaller neural networks, to medium neural networks, and going to the large neural networks. But one thing has to be noted, that when we were using traditional learning algorithms, uh, the less computation power was required to train these models that use traditional learning algorithms. But as we move on to the larger neural networks, more and more computation power and more data is required to train the model. So basically, what the heading of this slide says, that scale is a very big feature, is a very big thing that determines the performance of a learning algorithm. So basically, by scale we mean the amount of a data, and the amount of data is consistently increasing. Why? Because people are quite more oftenly using technology these days as compared to the earlier days, because we use technological things like mobile and laptops and watches, smartwatches, and these consistently and continuously capture data about human beings, and this data is further used to train the algorithms and give you some of the benefits. So basically, as the scale of the data is continuously increasing, so the performance of the learning algorithms is also increasing. And here, larger neural networks or the medium-sized neural networks plays a very vital role in getting the best performance. So this is the reason where we have a lot amount of data, but this in you can see this reason. So this is the reason where you have very small amount of data. Okay, so in this region where you have very small amount of data, the performance measure of all these four kinds of algorithm, that is the traditional smaller neural network, medium and large neural networks, this is not quite much significant, or we can say this is not in a very ordered way. Suppose that someone has a very good hand over applying traditional learning algorithms like support vector machine. which can also take infinite number of features. So someone has a very good hand in applying support vector machine rather than applying large neural networks. So he may find that the performance of the algorithm in support vector machine is quite much larger than compared to using the neural networks, large neural networks or medium neural networks. But this is only in the case of when we have a very small amount of data. So this when we have a small amount of data, the performance of the algorithm quite much more depends on the working hand, that is whether the person has much efficiency in applying the traditional learning algorithms or not, or whether the person is much efficient in applying neural networks or not. But when we have learning algorithm in this region, that is the region where we have a very large amount of data, then generally the larger neural networks or the medium sized neural networks performs much better than the traditional learning algorithms. Okay, so now, as I have already been saying to you, that scale plays a by scale what we mean as the amount of data plays a very vital role in the performance of the learning algorithm. So data we is a very vital factor. So this is the first point. Now another reason why neural networks are being taken off these days is the computation power. Earlier in the 19th century or very late, the computation power in the computers was not quite much efficient, and they could not train even a basic machine learning algorithm much efficiently, and it takes a lot of time for them to train these algorithms. And the third point you can see is the algorithms. So the algorithms that we are using today are getting efficient day by day. I'll give you example for this. For example, in the previous video lectures in this series of neural network and deep learning, we have a function called the ReLU function for classification. So what we have seen earlier is when we were using the traditional machine learning algorithms, then when we use the classification problem like the in the logistic regression, we generally use this kind of a function which ultimately tends to 1 like this, and here it tends to 0, and this is somewhat a kind of a threshold value. Okay, so this gradually, gradually goes and moves towards 1, and on the left side is gradually decreases, and it cannot be less than 0. So the advancement of this learning algorithm is, now we have, instead of using what this function is called, sigmoid function. This function is called the sigmoid function. Now what we have, instead of using the sigmoid function, we use somewhat a very advanced kind of a function that is called the ReLU function. Okay, so nowadays we use somewhat a very advanced kind of a function that goes to 0 or touches x-axis to some extent, and then suddenly it takes off. So this function that we are studying is called the ReLU function. I've already told about this ReLU function in the previous video lecture. This ReLU function is called as the rectified linear unit, and this is quite a more advanced function than we were previously using, that is the sigmoid function. So data computation and algorithms combined all together plays a very important role as to why deep learning are performing much better in these days. So let's move to the next one. Now you can see this continuous cycle here. So what we have is an idea. On the idea, we need to apply some kind of code, and by code we mean that we need to apply some kind of learning algorithm, and we need to deploy some data in it. using this learning algorithm with a specific amount of data, we need to perform some experimentation. For example, when we generally train neural networks, we need to set some of the parameters, and we continuously change on these parameters to gain much and more efficient performance of these algorithms. So earlier, when we have very traditional computers that were having very limited amount of memory and computation power, so these were not able to perform much well. Okay, so but now as the computation power has consistently increased, so earlier if an algorithm takes 1 month of time to train the algorithm, earlier the PC could take 1 month of time to train the algorithm, but now this time has consistently decreased to suppose say 10 days. So this is the way in which computation powers of the computers has significantly been increased, and this has helped us a lot. Okay, so basically whenever someone tells you that okay, so tell me that neural networks or the deep learning was a very older concept and why it is in a boom these days, so you can show all these graphical representation, and the one that we have used in this one, so you can draw this graph and tell them that what is the reason exactly as the deep learning is taking off these days. So this much for this video lecture. Thanks for watching this lecture, and keep watching my video lecture. Hope this lecture would have been very informative to you. More lecture would be uploaded soon. Okay, thank you.